Welcome to tonight's installment of our Driftless Dialogue series. Hand in the air if you've been to a lecture here as part of this series before. A lot of familiar faces. For those for whom this is the first, welcome. I'm going to start with our newly minted land acknowledgement statement, recently passed by our board. The Kickapoo Reserve Management Board acknowledges that the state and federal lands that comprise the reserve fall within the ancestral homelands of First Nations people, including the Ho-Chunk Nation. We recognize the sovereignty of the Ho-Chunk and other First Nations and will work towards a shared future by continuing to create collaborative opportunities to protect and preserve these lands. So I want to recognize also quickly our benefactors. The Driftless Dialogue series is supported by a grant through the Ralphie Nuzum Kickapoo Valley Reforestation Fund, allocated through the College of Ag and Life Sciences down at UW-Madison, and also the efforts in support of our Kickapoo Valley Reserve Friends group. Our speaker tonight is Rick Lindroth, and I'm going to give Rick a brief introduction. When I'm tasked with introducing speakers as part of the Driftless Dialogue series, I go online the afternoon of the talk and do a little research, and I pulled up Rick's 51-page curriculum vitae, or resume today, and perused some of the 300-plus publications, scientific articles, book reviews, book chapters, presentations given, it seems, in every corner of the country, if not the world. And I thought, that's way too much. I'd take up Rick's entire speaking time. So I'm going to give you a little bit of background by way of introduction for Rick. Rick Lindroth is Vilas Distinguished Achievement Professor and former Associate Dean for Research at the University of Wisconsin-Madison. He's a broadly trained ecologist with expertise in global change ecology, including climate change, biodiversity, plant-insect interactions, and plant chemical ecology. Rick has a personal interest in the interface of science and religious faith. He's authored over 200 publications with support from the National Science Foundation, the U.S. Department of Agriculture, and the U.S. Department of Energy. He's been a Fulbright Fellow and is a Fellow of the American Association for the Advancement of Science, the Ecological Society of America, and the Entomological Society of America. And Rick's here tonight to talk about climate change and the pursuit of truth in a post-truth world, which just sounds scary to me. Join me in welcoming Rick.
Well, thank you, Scott, for that really nice introduction. You know, a 51-page CV, whatever, it just means that I'm old, right? And thank you all for turning out tonight. I did say to my wife, Nancy, who's here with us tonight, I didn't know if the rain would keep people away or bring people in, probably some of both. But thank you all for joining us here tonight. I think it's going to be a fun time together. I look forward to your comments, and hopefully you can learn some things as well. So, my PowerPoint is giving me suggestions on what I ought to be doing right now. So, okay, let's get rolling. A little bit about me. I'm a professor of ecology at the University of Wisconsin-Madison. I do research, as Scott had indicated, in global change ecology, biodiversity, evolutionary ecology, and over the last 10 years or so, because of my deep, I'd say passionate interest in climate change and environmental issues, I've done a bit of a deep dive into science, especially climate change communication. One thing that Scott mentioned is that I was the Associate Dean for Research. I started my position the same month that Scott Walker was elected and served for 6 years, ended it the same month as Donald Trump was elected. So an interesting 6-year span. And during that time, I actually administered the Ralph Nuzum funds that provide funding for this lecture series. So it's kind of interesting to be on the other side of it now. So thank you. Thank you, Summer. Thank you all for the invitation. Every year, the Oxford Dictionary of English comes up with a single word that best describes to them the ethos, the issues of the preceding year, and a word that they feel is going to continue having cultural significance into the future. In 2016, that word was post-truth, a situation in which facts and objective evidence are trumped by existing beliefs and prejudices. I'm not laughing, you're laughing, okay? So I'm not going there. I think I just keep this apolitical. In 2019, the word was climate emergency, a situation in which urgent action is required to reduce or halt climate change and avoid potentially irreversible environmental damage resulting from it. And what I'll argue tonight is that the occurrence of these two words of the year in short succession was not just a coincidence. And we'll do a bit of a dive into that relationship tonight. So where are we going? First of all, I'll talk some about the nature of science, then the science of climate change, very briefly, communication across cultural divides, and finally end up with what does climate action require? So that's the roadmap for this evening's talk. So first of all, what is science? Well, really, very simply, it's the systematic study of the structure and function of the natural world. Ecologists, and I'm really trained as an ecologist, that's my most generic scientific description, are those people who study the interactions that govern and that rule the natural world. So science, contrary to what a lot of people think, is not just a large body of complicated facts. Rather, it's a way of knowing, it's a way of understanding the world around us. And it's accomplished through this cyclical process, including observation. So you make some observation about the world. For example, the species of trees that occur on the uplands here are different from those that occur in the lowlands, or that geese flying on their migratory routes fly in the shape of a V. Some observation about the natural world. Then we form a hypothesis. We ask questions and we form a hypothesis, like a prediction or a possible answer that would describe why that pattern exists. Then we conduct experiments or we do mathematical modeling, further observations to test that hypothesis. We analyze the results. We hopefully can publish those results. And then we repeat the process, refining our questions with each cycle. So that's the scientific process. It's proved very, very powerful in understanding how and why the natural world works as it does over the last 200 years. But there are two problems with science in a hyper-polarized world. And the first one is that science tends to be complicated. And I love this quote by Alexis de Tocqueville, who was not a scientist and was not writing about science, but it's still germane. He wrote this in his book, Democracy in America, in the early 1800s. An idea that is clear and precise, even though false, will always have greater power in the world than an idea that is true but complex. And I think we've all seen that over the course of the last few years, whether we're talking about vaccinations or pandemics, climate change, you name it. The second problem with science in a hyperpolarized world is that the fundamental nature of science actually predisposes it to denial. So we need to understand that science technically doesn't prove anything. Science is a systematic process of uncertainty reduction. So we take away uncertainty, and then we kind of come down to what we feel is true. But if we come up with another study that would refute that, then we'll change our theories. So it's a process of uncertainty reduction. And what that does is then it provides this provisional nature to scientific conclusions. They could always be changed. We might learn that actually gravity doesn't exist, or it doesn't exist in the way that we think it does. And if substantially proven, we'll change our theories about gravity. Well, this provisional nature of science can be manipulated by people who stand to benefit by doing so. And certainly there are many of them. So Lee McIntyre, who recently published a book just this last fall titled How to Talk to a Science Denier, says that science denial is not an error, It's a lie. Disinformation is intentionally created. So we have information, we have misinformation, that's simply wrong information, and we have disinformation, that is wrong information purposefully perpetrated to achieve some other goal. So then you're probably asking, well, if that's true about science, how do we know what is true? Or how do we know what is and what isn't scientific truth? So let me give you a very brief overview of some of the hallmarks of what is pseudoscience and what is science denialism. And the first one is that they have impossible expectations for what science can achieve. Well, you really can't prove that smoking causes cancer. You can just show me that it's associated, but it might be caused by something else. Okay, so impossible expectations for actually defining that this is a scientific truth. Another hallmark of science denialism and pseudoscience is the use of cherry-picked data. That is, selecting particular data points but ignoring large other bodies of data simply to prove the point that you're trying to make. And I'll give you one, I think, really good example of this. It's getting a bit old, but here we see a plot of Earth's surface temperatures from 1880 to 2021. Well, actually, on this slide, you see only 2 years, 1998 to 2008. And these are temperatures anomalies. So these are differences from kind of the long-standing historic temperature of the Earth over hundreds of years. It came out, there was a publication published in 2008, and it showed that actually over the preceding 10 years that the Earth's temperature, the average Earth temperature, had declined. And boy, that just spread like wildfire. And it was all over the news. It was in newspapers, it was on conservative talk radio, it was on conservative news stations. And actually, this perspective that the Earth is cooling is still remains today. One of our very own senators said just about 2 years ago that, I won't use a gender-specific term because then you'll know who it is. This senator said that they think that the Earth is still cooling. So, but those are cherry-picked data. What does the whole suite of data show? The whole suite of data shows this. These are the average temperatures over every year. The red line represents the best fit. And clearly, there is an upward trend that is different from these two particular cherry-picked points from 1998, which happened to have been an El Nino year, which was very warm, and 2008, which was unusually cool. So that's what we mean by cherry-picking data. The use of fake experts is another hallmark of science denialism. People who may have a degree, but probably isn't a degree in anything related to what they're talking about. And the denigration of real experts. Oh, they're just in it for the money, or they're doing it for some other nefarious reason. Logical errors. Oh my gosh. It snowed last Saturday. How can climate warming be occurring? Okay, well, climate warming is about more than the weather in one location on one day of the year. But those types of logical errors creep in. Conspiracy theories. The scientists are in cahoots, or there's a conspiracy to hoodwink the rest of the world. And for people who don't understand how science operates, for those of us in science, that's really kind of a hilarious mistake, because science is highly, highly, highly competitive. It's uber competitive. A couple of years ago, I had a grant proposal in that was ranked 5 out of 99, top 5, number 5 out of 99, and was not funded. That's how competitive some fields of science can be. And so what scientists are doing is scratching and clawing, trying to get their way to the top of the heap so that they can get their research funded. And you don't get it funded just by going along with what everybody else says. In fact, if it was possible to disprove climate change, whoever does so would get a Nobel Prize. And who wouldn't want that? right? So the idea that we're kind of all in lockstep in cahoots trying to hoodwink the public, just people who believe that don't understand how science operates. The use of non-peer-reviewed sources and outlets for information and communication. So people who are trying to deny climate change or other things typically don't publish in peer-reviewed journals. In fact, they can't, not because their information would not be publishable, but because it doesn't have the scientific credibility. They've not gone through the sufficient quality of science in order to be published. I serve on multiple journal editorial boards. I've worked with the NSF, with the USDA. I can tell you, and you just have to trust me, so you don't know me, so you don't have to trust me. But if the science is good, we'll publish it. Okay? It's not like we have a vendetta against certain types of science. If it's solid science, we'll publish it. All right, well then how do we discern what are the hallmarks of trustworthy climate science information? The first is that it's published in peer-reviewed journals. The second is that they will incorporate large and diverse bodies of data. And third is that they're backed by recognized scientific organizations and agencies, things like the National Academies of Science or the National Science Foundation. There are actually worldwide 201 scientific societies that have posted public statements on human-caused climate change. 201. And of those 201, 198 concur that it's real and that it's human-caused. 3 are non-committal, and those are geological associations. 0 of them are opposed. All right, so now let's do a very quick overview of climate change, what many scientists are calling the existential crisis of our day. Let me back up. Climate change is controversial in many arenas of human endeavor. It's controversial in politics, it's controversial in economics, in religion. The one arena in which it is not at all controversial is science. So that's what I'd like to present to you tonight. Very briefly. And I'm not a politician. I'm not an economist. We can talk about some of those issues if you'd like toward the end. I'm just going to give a very brief overview of what does the science say about climate change. And I can do it in 17 words. All right, here it is. It's real. It's us. It's bad. It's going to get worse. But there's hope if we act now. The science of climate change in 17 words. So let's dive into each of those. It's real. The 10 hottest years in history have all occurred since the year 2000. The past 7 years have all been the hottest in recorded human history. And you can see the graphics there from the blue, the cooler temperatures, up through the 2000 and 2020. Man, we're really getting warm. And here is the same type of graphic, but summarized on the basis of decades rather than individual years. What's happening in Wisconsin? This is a great report, just came out a couple of months ago, Wisconsin's Changing Climate. And here we see temperature change in Wisconsin. Again, a lot of up and down, but the gradual trend is up. So in Wisconsin, we see that the average daily temperature has increased 1.7 degrees C. That's a little bit more than the global average since the 1950s. Warming is happening fastest at night. So nights are more warmer than days are warmer. And in the winter, precipitation has increased by 17%. That's 5 inches a year. So we're, roughly around 34, 35 inches a year historically. Now we're closer to 40. That's a substantial increase. And you won't be surprised to know that those increases are largest in southern Wisconsin. And we've seen, again, you won't be surprised to hear increases in extreme weather events. And I'd love to hear your insights on some of those toward the end tonight. Science has documented over 26,000 different indicators of a warming climate. We have things like increasing sea level, decreasing sea ice, decreasing glaciers, shifts in the species range of all kinds of plants and animals, increases in temperatures over land, increases in temperature in the sea, increases in temperature in the atmosphere, changes in humidity, all kinds of indicators of climate change. Lake Mendota, which is the largest lake in Madison, is one of the longest running indicators of climate change, because for over 120 years they've been documenting the time of complete ice over and the time of ice out of the lake. And sure, there's a lot of variation from year to year, but the overall trend is downwards. Whereas in the 1800s, when they first started, it was about 120 days of solid ice per year. Now we're down to around 80, so about a 1/3 decline. Some of you are saying, and I hear this all the time, but yeah, the climate has always been changing. And that's exactly right. It's always been changing because of things like changes in solar insolation, changes in the Earth's orbit, in the Earth's wobble, changes in volcanism. There have been vast numbers of changes in the Earth's temperature. Not during human history, by the way. During human history, it's been very, very stable. But if we look at the, 4.5 billion year old history of the Earth, we've seen vast changes in climate. How do we know that? We know that because of the work of climate scientists. What do those very same climate scientists tell us is driving the change that we've been seeing over the last few decades? None of those factors, it's increases in greenhouse gases. So why is it that some people would actually have no trouble believing what the climate scientists tell us about what happened hundreds to thousands to millions of years ago, but have difficulty accepting what they tell us today? In fact, here is a graphic showing that many of these other factors are not changing substantially over time. On this graphic, we have things like solar insolation, the amount of solar radiation we're receiving, sulfates in the atmosphere, which are an indication of volcanism, ozone, volcanic activity, etc. And on the upper left, we see temperature increases. The only factor that comes close to approximating that is this kind of purple-blue line, which is the increase of greenhouse gases. Greenhouse gases are gases that absorb heat. So the sunlight comes in, it comes in as visible light, hits the Earth, gets absorbed, gets re-radiated back into the atmosphere as infrared or heat radiation, and then gets trapped by molecules in our atmosphere that trap that heat. And those are especially carbon dioxide and methane. Water does as well, but water is not a major shift. The contribution of water is not shifting over time like the contribution of CO2 and methane. Here we see the major contributors of greenhouse gases emissions. The bluish is carbon dioxide, the rust red is methane, nitrous oxides, and then we have actual reported observations of CO2 increases based in Hawaii, the Mauna Loa Observatory, over the last, in this case, about 60 years. So we're seeing this gradual and an accelerating increase. There's also this up and down, which I'll tell you happens on an annual basis. So it's real, it's us, it's bad. Climate change is impacting all regions of the world and all sectors of our economies and lives. Every 5 years, the US government comes out with a national climate assessment. This was the 4th one, came out in 2018, I believe. And it shows, it's really a good publication if you want information on what all is being impacted. And it's across the board. I mean, we're talking about economics, infrastructure, national security, you name it. Now, we all, I think, probably have personal examples of climate change. Here's one, and it's related to another passion of mine. This is Black Earth Creek, just to the west of Madison. Historically, a blue ribbon trout stream. And I do love to trout fish. This is what it typically looks like. In August of 2018, this is what it looked like. Wall to wall in the Black Earth Valley flooded because of 14 inches of torrential rainfall. It's the same storm that washed out much of the Kickapoo River, right? And so I'm sure many of you probably experienced that same storm. And I'd love to hear some more of your stories at the end tonight about components of climate change that you've experienced. Projected changes in the distribution of trout are shown here. I love trout fishing. I'm an avid fly fisher. And I have to say, this makes me really sad. So brook trout habitat over the next roughly 50 years, actually 30 more years from now, we expect to see a 68% decline in brook trout range in Wisconsin. So the shift of green to red indicates a loss of brook trout habitat, and a 32% decrease in brown trout habitat. Now, I don't know if many of you are fisher people, but you probably know that this region is really popular among fishermen and women. I have to include my wife now because she fly fishes also. Fly fishing brings in $1.5 billion a year to the driftless region. I know that because about $1 billion of it is mine. But I mean, it's a significant economic driver to this region, and we're concerned because of things like this changing and what the economic impact will be. Here we see a slide showing billion-dollar disaster events in the United States from 1980 to 2020. The dark line, this one here toward the bottom, that's the average over that 40-year period. And then all these colored lines, 2018, 2019, 2016, 2011, 2017, 2020. If we had 2021 on here, it would be right below the 2020 line. So again, over the last 10 years, we're seeing more and more billion-dollar disaster events in the United States. And this is a quick summary, we won't go into detail, of the weather and climate damage in the United States just over the course of last year, totaling to $145 billion, from wildfires in the West to, I mean, who's ever heard of tornadoes in December in the Midwest? But we had them, right? Significant ones. Derechos, these straight-line windstorms, hurricanes, which are not increasing in number, but are certainly increasing in magnitude and duration and intensity related to climate change. So like I said, climate change is affecting every facet of human life and the natural world as well. Here's an example of the types of major federal documents and related documents that have come out reporting the impact of climate change on different social sectors. Everything from economics to agriculture to natural resources, human health, poverty, transportation and infrastructure, and national security. All of them are being currently affected and will be affected even more because of climate change. Well, that's the good news. The bad news is it's going to get worse. The climate change that we've experienced over the last 10 to 20 years is not a consequence of the CO2 and other greenhouse gas emissions we've had in the last 10 to 20 years. It's a consequence of the greenhouse gas emissions we've done over the last 30 to 50 years. There's this long lag period in the climate system, whereas if we emit CO2 today, it will take decades to 100 years for the Earth to fully absorb that and change accordingly. So even if we stopped emitting greenhouse gases today, the climate would continue to change for the next 100 or even longer years. And so human society, human civilization, has already left the stable climate zone in which we have flourished for 200,000 years. And there's no going back in our lifetimes or the lifetimes of our kids. It's going to be a new climate zone that humans have never occupied previously. The last time that global temperatures were as high as they are now, sea levels were 20 to 30 feet higher. So if we just keep this global temperature now, sea levels will go up, and most of our major coastal cities will be significantly flooded or worse. The last time that global CO2 levels were as high as they are now, sea levels were 65 feet higher. So again, there's that lag that gets built in. So we will be moving in a seriously bad way. The Paris Agreement of 2015 set 2 degrees C as an upper kind of safety boundary. That was a political decision. The scientists wanted it much lower, and so they also set an aspirational goal of 1.5 degrees C warming to try to achieve that. Well, of that 1.5 or 2 degrees, we've already warmed 1.1 to 1.2 degrees. So we have only less than a degree left to go before we hit that 2 degree upper limit. So we're now, as I mentioned, committed to inhabit a climate zone never before experienced by humans. And to stay within that 1.5 safety zone, we need to cut global greenhouse gas emissions by 45%, nearly by half, by the year 2030. So that's a really, that's going to take a lot of action. Bringing it back to kind of nearby or back to home, what would the climate of Madison, Wisconsin feel like in 60 years with our current emissions scenario? In 60 years, we would be very much like Lansing, Kansas, home of the University of Kansas. That would be like 7 degrees warmer in the summer and 12 degrees warmer on your average winter day, and more humid throughout the year. And unfortunately, climate change and other environmental problems are fundamentally issues of economic, social, and racial justice. Non-white, low-income, and indigenous communities are strongly, disproportionately impacted by climate change, by pollution, and by land degradation and other environmental degradations. Climate change disproportionately affects those living in poverty. This is a bit of an old graphic, but it gets the message across. Here we see total greenhouse gas emissions in the year 2000 by country. The warmer the color, the greater the greenhouse gas emissions. So as you can see, highest in the United States, Canada, China, Russia, lowest in Africa, South America. This is the estimated number of deaths attributed to climate change in the year 2000. You can see they are strongly inversely correlated. The countries that emit the most have the lowest number of deaths. The countries that emit the least have the highest number of deaths. Again, it's a function of magnitude of poverty in these countries. The good news, though, is that there is hope if we act now. And there are many, many reasons for hope. We've seen really tremendous advances in technology, advances that nobody would have dreamed of 10, 15, 20 years ago. We've really, like in terms of solar energy, wind turbine energy, and others, battery cell production, all of these have been really remarkable advances. We're seeing corporate commitments from major companies, the greening, as it's called, of religious institutions, a lot of social action among various groups, especially the youth, and major government agreements, and anywhere from small villages up to international agreements. So there are many reasons for hope for the future. And we've actually made progress in slowing the rate of climate change in recent years. 10 years ago, the anticipated climate change by the end of this century was expected to be upwards of 4 degrees C. Now, only 10 years later, we're thinking, no, 3 degrees C is probably the upper end. That's a huge improvement. Now, 3 degrees C is still going to be an awful lot of change. Things are really going to be bad with a 3-degree temperature differential, but it's way better than 4 degrees. So we are seeing significant improvement already. Another reason for hope is that we have multiple very good roadmaps toward a sustainable climate. We have a number of government agencies, think tanks, and others that have produced these various roadmaps to tell us how do we get from here to there? What needs to be done? And in fact, The Intergovernmental Panel on Climate Change, the IPCC, that comes out with a report every 5 years. This year, meaning last year and this year, they came out with 3 reports because it had gotten so big. The one that came out just 2 weeks or so ago is indeed pretty much a roadmap saying, what do we need to do to get from where we're at now to stay under the 1.5 to 2 degree ceiling in climate change? We know what to do. And that's really good news. I mean, can you imagine if we didn't know what was causing climate change, or if we didn't know what to do about it? We'd be in a world of hurt. But we know why it exists, and we know what we need to do. Here's an excellent resource if you're looking for suggestions for how to address climate change with respect to any of the many human endeavors and activities. Project Drawdown covers food, agriculture, industry, health and education, buildings, transportation. Just go to projectdrawdown.org. They actually have little models or interfaces that users can go to, and you can plug in information and it tells you how effective that potential change to human activity will be in terms of reducing climate change. So that's kind of a fun resource. I just mentioned the 6th IPCC assessment, and this is the volume 3 that came out last week. Their summary is that it's only political will that stands in the way of meeting the Paris Agreement targets. It's only political will. We know what the problem is. We know how to fix it if we only had the political will to get there. And there are going to be tremendous associated benefits. We'll have a stronger economy, cleaner air, improved health, improved energy security, improved water and food security. And now, as we all know what's going on in Ukraine, we would have improved national security, because how much of the situation in Ukraine and Russia and Europe is being driven by the fact that Russia is supplying most of Europe's fossil fuels. So then, what's the problem, right? If we know what is causing climate change, if we know how to fix it, why don't we just do it? Well, that's the rub. What I'd like you to consider for a moment is, what would you say is the most important demographic factor that describes people's perspectives on the reality of human-caused climate change? By demographic factors, I'm meaning things like age, sex, education, location, religiosity, all of those descriptors that we can use for kind of describing humans and human societies. Of all of those, what do you think is the very, very best indicator of where a person stands on whether climate change is real and human-caused? I'd like to hear a couple of ideas. Anyone want to be brave? Just raise your hand. Yeah?
Education.
Education, okay. Yep, I would agree with that, yeah.
Political party.
Political party, okay. Others?
Age.
Age, okay.
Ability to openly communicate.
Ability to openly communicate, great, okay. Okay, sorry, lady in the yellow fleece, you win the prize. Political party. And it's interesting, it's not even political ideology, it's political affiliation. Is the #1 strongest by far indicator of where a person lies on the continuum of believing that climate change is real and human-caused versus not. It's not education, right, which seems to run contrary, and it's not age so much, it's political affiliation. It's not even political ideology. It's which party do you affiliate with? Well, why is that, right? That's kind of strange. And that's what I'm going to dive into for the next 10 minutes or so, wrap up tonight. So when confronted with new information, how do we as people determine whether or not to believe it? Most of us would say that we kind of rationalize it, we reason it through, and if it seems credible, if it seems reasonable, we incorporate it into our worldview. That's what most of us would say. We think we're children of the Enlightenment, very rational, very reasonable people. And we would be wrong. because that's not what we do. None of us do. Maybe a little bit, some more than others, but by and large, that's not what we do. We first intuit a response to this information. Does it jive with our identity, with our values, with our moral frameworks? And then we use our reasoning capacity to confirm why that intuition is correct. So we think that we actually reason and then we intuit following, but we actually intuit and then use the reasoning faculties to provide the proper spin for why that intuition is correct. So climate change denialism is not really a consequence of insufficient information. It's a consequence of identity. And that's why political affiliation is such a good indicator of where a person lies on that spectrum. Denialists don't have an information deficit, they have a trust deficit. It somehow, the information conflicts with who they view themselves to be as a person. So unfortunately, the climate change issue is stuck in this cultural divide. And now we will just venture into politics very briefly. People connect to the issue based on their cultural and tribal identity, and they filter information through their moral frameworks. So liberals historically have viewed environmental issues as moral issues, as matters of right and wrong. Conservatives typically don't. For decades, the climate change narrative has derived from and reinforced liberal values. Liberals tend to value things like care and fairness. Conservatives have viewed climate science and especially climate science or climate change solutions as attacks on their identity and attacks on their values because they prioritize loyalty, authority, and sanctity. So the climate change issue then is stuck in this divide between tribal affiliations. Recently, and only recently, I'm happy to say that there is an informed conservative narrative on climate change and climate change solutions that is beginning to emerge. There are a number of federal representatives and senators who have said, okay, we now agree it's happening, it's serious, and we need to do something about it. We'll take a different approach from the liberals, but it still needs to be addressed. Amen. Let's go for it. So let me suggest then a model for science communication across these cultural divides. And the important thing to remember is that denial is more about identity than it is about information. And this is where scientists really run into trouble, because when we are confronted with denialists or dismissives, whatever we want to call them, our knee-jerk reaction is to what? Dump all this information on them. Here's the data, here's the data. It doesn't matter what the data is, right? There is no one more experiment that could be done that is going to convince a denialist that they're wrong. It won't happen because it's not a matter of information, it's a matter of identity. Our goal then should to help denialists and dismissives to switch perspectives without challenging their identity. That's the challenge. They already have the values that they need to care about climate change. Who doesn't care about having a clean environment? Who doesn't care about what kind of world your children or your grandchildren will inherit? So what I would recommend is the first thing is, for all of us, be aware of our own values and how they color our own perceptions about the world. And secondly, to model epistemic humility. That is, what is true and how can I know that it's true? What I like to say is that objective truth exists, it's out there, but my own ability to discern it is imperfect. So I, as a scientist, have to be humble and show some humility about my own grasp of what I think is true. Build trust and use empathy. Frame the communication to connect with the person's identity and values. So I mentioned I like to fly fish. I do some bird hunting. I do other kinds of fishing. Outdoors people tend to be, on the political, liberal, conservative spectrum, tend to be a little more conservative. But I can identify with lots of outdoors people because of our common value and shared interest in doing things like hunting and fishing, right? And then provide a clear, non-threatening message that shows that the person's beliefs about climate change actually are in conflict with his or her own values. Now, this is not easy, and it needs to be done kind of very slowly, step by step, but I think that's the best promise for having an effective form of communication. And then I would argue we need to focus our attention on people in the middle of this denialist acceptance spectrum. So most recent research based on surveys of about 1,000 Americans is that 31% are alarmed about climate change and very concerned and motivated. 10% are highly dismissive. We're not going to convince the dismissives. It's just not going to happen. Most evidence would suggest that. So don't try to do so. I'm not much in the public eye, but I have a Twitter account and I have some other things, and I give public lectures like this, and occasionally I'll have a negative, really nasty interaction with somebody, and don't bother trying to change that person's opinion. It's just not going to happen. But focus on these people. Don't step on the cord. Okay, good. Focus on these people here in the middle. Those are the ones that we have hope of influencing. What will effective climate change action require? Transformational change at all levels of human experience. Individuals, families, faith-based communities, schools from elementary school to universities, corporations, and governments from local to international. It's going to take all of that. There's not going to be one silver bullet that effectively addresses the issue. And there is this debate now between conservative and liberal approaches to dealing with climate change, between liberal and conservative politicians, as to whether we should emphasize individual action or systemic action, especially government action. Of course, conservatives are saying we should leave it up to liberals. Leave it up to liberals, sorry. Somebody else said that would be good. I did not say that. Leave it up to individuals and corporations and businesses to do the right thing. Liberals, of course, would like to see more government action. Most scientists would say it's going to take both. We've got to have both. And it is a systemic problem, and it will require some systemic fixes. So just relying on individual goodwill is not going to fix anything. I'm old enough to remember when rivers used to catch on fire. And some of you are too, right? The 50s, the 60s, 70s was an era of really dramatic environmental degradation. Our air was much worse. Our water was much worse. We had acid rain. We had all kinds of severe environmental problems. And environmental issues were not as partisan as they are now. We had Republicans and Democrats who came together and passed monumentally important environmental regulations. We had a president who was a Republican create the EPA. And so we had bipartisan support for caring for the environment. We've seen dramatic improvement in many aspects of our environment over the last 50 years, really dramatic improvement. How many of those dramatic improvements happened without federal legislation? Zero, none of them. So the idea that we're going to be able to fix something as substantial, widespread, and massive as climate change without government regulation, I think, is naive. Okay, how should we live? Some suggestions for us as individuals. First of all, I say that we care for the things that we love, and we love the things that we're intimately connected to. So I encourage people to spend time out of doors, spend time connecting with nature. A naturalist and artist I know in California, when asked a similar question, what should we do, has told people, go put your feet in a river. And I really like that because it's helping people to connect with the natural world. So programs like this, institutions like this, places like this are really important for establishing that nature connection. Learn. Then learn about your natural environment. Learn about issues. Learn about the things that we can do as individuals, as families, as groups to counter climate change. Katharine Hayhoe, a prominent climate scientist, when asked what's the most important thing that we can do, says talk about it. We just don't talk about it enough. Talk about it among your family members, in your churches, in your clubs, in whatever setting. Act, take independent individual action. I know that any one individual action is not going to make any change whatsoever in our climate. Nancy and I just put in a very expensive heat pump-based HVAC system into our house. So it's a heat pump that will provide cooling in summer and warming in the winter. And it's also, because we live in Wisconsin, also is linked to a standard high-efficiency gas furnace. We put a lot of money into that. It's not going to make any change whatsoever in the global climate. And we know that. But we feel morally impelled to do so. We feel that it also provides a model to those around us. And enough people do that, then you see the good consequence as the aggregate outcome. And then finally, vote. I'll go back to it's only political will keeping us from reaching those Paris targets. And so we need people in office who view this as a serious problem. Some of you are probably asking what would be my go-to recommendation for a book dealing with this, and I really like this one by Katharine Hayhoe. It's fully accessible to everybody in this room. If you can read, you can understand this book. And it addresses not only kind of the science in straightforward terms, but also what we can do about it as individuals and how we should be communicating. So Saving Us just came out last fall. And if there are some other additional resources, here are some that you could start with. There's so much available online. Just Google 50 things to do to stop global warming. Skeptical Science, it's kind of a misnomer. Skeptical Science is a terrific website dealing with all different aspects of the science of climate change and climate change communication. The Citizens Climate Lobby is a political action group. And then Katharine Hayhoe, the same author I just mentioned, has a whole series, like 30-some different YouTube videos, most of them like 7 to 10 minutes long, dealing with different aspects of climate change. Again, very easily accessible, very informative. And there you go. Happy to take comments or questions. Yeah.
So I've kind of been involved in that whole energy aspect of climate change. And so I've been really trying to understand the position of the utilities. And so I'm going to kind of speculate a little bit, but I think this makes sense. That is that the fossil fuel industry has created contracts with certain utilities, and they're long-term contracts.
Mm-hmm.
So they want to build more power plants, gas power plants, and yet you look and you see the technology is evolving very quickly. And so, and the message is, well, solar, wind, it's not reliable enough, so you need this to supplement that. Okay, well then battery storage, that's really evolving quickly. So when you look at the risk, or where should you put your risk? Should you risk that this is going to evolve, this technology is going to evolve, and we'll be okay, we can do that? Or do you say, okay, let's go for the safe part here and build this power plant, but then we have to pay for it and it could become a stranded asset.
Right.
So it's
Yes.
like really, 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 really hard. And so I guess I'm really interested in your thoughts and anybody else's thoughts about, how to show compassion to these people who've made these decisions with information provided by the fossil fuel industries for years and years. And we're kind of like
yeah, what do we do about utilities and transitioning from classical fossil fuels to these new technologies that may or may not work? And the major investments that we have in the infrastructure, the major investments it would take to build new power plants, which then may become stranded if the new technologies catch on. You know, that's out of my wheelhouse, unfortunately. I would say we definitely, I mean, think about how much government subsidy goes into maintaining and developing and finding new fossil fuels. It's enormous, billions and billions and billions of dollars to sustain a fossil fuel-based economy. If we took a fraction of that, a small fraction, and put that into renewable energy research and development, we'd be light years ahead. So it's not really so much in either or, you know this, but we need to hasten the development of the new technologies, take some risks, but we can't take a lot of risks because we can't have people and industries going without energy, right? And I think that we do need to be thinking of these transitional periods, transitional fuels. So natural gas is being considered a transitional fuel. We're going to need something to transition us from where we're at now with a heavy reliance on coal and oil and natural gas until we get to the future where we can rely on more of the renewables. That's the best I can do, and I'm happy if somebody else has some expertise in that area to comment as well. Yeah.
I'll try and keep the question short.
Okay, all right.
I downloaded the IPCC report, volume 3, and I've been reading it.
Okay.
And I find it almost incomprehensible, unfortunately. So
Okay.
I'm glad you mentioned drawdown.org, but you also did mention the roadmaps in that report.
Mm-hmm.
You also had a slide with some additional roadmaps.
Yeah.
Would you say that drawdown.org or Catherine's book would be a layperson's guide to those roadmaps?
Yes, drawdown.org. Go to that one. And Catherine's book, it covers a lot of territory, so it gets into some of that, but not at the level of drawdown.org does. So Drawdown is really a good resource.
Okay.
Yeah. When you downloaded the IPCC report, there are there's a summary for, what's it called, summary for policymakers.
Yep.
That's written in a little more comprehensible way, but not so much. Okay, all right.
Yeah, I started with that one, and honestly, the problem I have is so many of the citations and the notes,
Yeah.
and even the acronyms and the abbreviations.
Oh yeah,
Really
yeah.
disrupt the flow of that.
You're right. You're right. Yeah, it's written like a scientific paper.
Yeah.
Yeah, right.
There's your problem.
There you go. Yeah, exactly. Yeah.
Again, I'm interested in your statement that the primary predictor of whether or not people accept or deny climate change is their political affiliation. How, I mean, that is upsetting because it makes everybody seem like sheep, right? You're just following along with what you're told.
Right.
How entrenched or how maybe malleable are those beliefs? You mentioned that there are conservative leaders in the federal government now who are starting to move away from that view. As they speak out as climate change acceptors, are they going to be able to hold their base with them, or are they going to get voted out of office at the next primary?
Oh gosh, yeah, I wish I knew. So yeah, how malleable are people's beliefs, political beliefs, and their especially their affiliations? This is the question. And are politicians taking a risk in moving in that direction, or are they going to be voted out? Let's look at what happened at the last midterm election. So this is, I just have to remind myself, what year are we in? This is 2022. So 2020, we had midterm elections. Oh, that was a regular, yes, thank you, sorry. The coming up is midterm, thank you. In that election, Republicans who moved toward the center lost, and Democrats were elected instead of them. So unfortunately, that election showed that if you're going to be electable as a Republican, you need to stick with or move further to the right, or you'll lose your seat to a Democrat. I'm sorry, that was just an awful, awful finding, in my estimation. I would love for both parties to become more centric, but we're just seeing the opposite. They're just getting increasingly polarized. So I think, I think it's malleable. I think people will shift can change their affiliation, or perhaps best change the political ideology. But until politicians can see that they won't be voted out of office, I don't think it's going to happen very, very rapidly. And so, I have people in my own family who, their political ideology will turn 180 in order to stay with the affiliation that they have. And so, and that's typically more on kind of religious perspectives. I don't want to get too much into this, but prior to Trump, there were people in the conservative Christian community who would say, we need a person in office who is a godly person, in speaking of the present man, who had the right character, the right moral values. Well, then we see somebody come along who does not exemplify those, and so the ideology switched, but the affinity remained, right? Now all of a sudden it's okay to have somebody like that because we're sticking with the affinity for that political party. So, okay, I don't want to, I'm a little bit nervous getting into that too much. Is there, yeah?
Well, I had a question about this. Worldwide, how prevalent is this strong partisan divide? Is this unique to the United States?
Yeah.
Or is it?
Yeah, so, okay, really good question. Yeah, is this uniquely a United States problem? No, I think it's uniquely bad in the United States, but we're seeing the politicization occurring in many places in Europe, certainly Australia, even Canada, the whole Brexit thing in England. So yeah, it's particularly bad, I think, in the United States, but it's not uniquely so in the United States. And it's not Republicans versus Democrats, it's social democrats versus whatever else they might have. But I think the issues are similar. Yeah.
Part of my interest is in educating the next generation.
Okay.
So teaching love for the earth, spending time outside, all those things I absolutely agree with. And I challenge myself to know when is it appropriate. Do you have any opinions on developmentally appropriate levels of information about climate change, activism about climate change? When is it more harmful to teach a young person how bad it is, for instance,
right. Yeah.
versus teaching many years of love and then teaching?
Excellent question. So yeah, developmentally, when and how rapidly do we reveal and teach our young people about the issues we've been talking about tonight? I have 3 grandchildren, ages 9, 6, and 3. So that's a concern I have. Fortunately, their parents are very concerned about these issues as well as the development of their kids. I'll mention one of my very favorite books of all time because it helped to describe my own self as well as how to help children along this line, and that's Scott Sampson's book, How to Raise a Wild Child. So buy it, read it. It's wonderful. And it talks about what do we do with children of different ages, different age categories, to help them to connect with nature, all the way up to adults. How to Raise a Wild Child, the art and science of nature connection. So yeah, you don't want to freak out your kids. There's a time for that. So we've always emphasized, and my kids emphasize, having them fall in love with nature. And then as they're starting to get into elementary school and beyond, they're getting exposed to this, and then the parents are living lifestyles that demonstrate care. Of course, if you're a teacher, you can't do that so much. But it's just a slow progression that takes into account their mental, emotional maturity, right? So I don't have hard and fast rules, but certainly it's a progression. Yeah.
Rick,
Yeah.
Andrea Demick's book is really great for upper elementary.
I was looking for a blackboard.
Oh.
Andrea Debbink, Debbink. She has written
It's called Handbook, something, Wildlife Handbook, no, that's the
She's written 2 books recently, just published. If you just look up Andrea Debbink in Amazon, you'll come
The
up.
first one is about habitats, and it has little biographies for kids to read of things that are happening to the environment and how someone took action to make it better.
Mhm.
And it's such a hopeful picture
Yeah.
of bad things happening, but someone making a change.
Yeah, yeah, they're really good.
They're wonderful books.
She's actually based right out of Madison. Yes?
In your graph, you were showing how the Earth was warming up with a certain period of years. Do we have any way of knowing what was 300 million years ago?
Yes, we do. And there, what's that?
Well, I have another question. I just wonder if the dinosaur is going to come back.
Oh, is the dinosaur going to come back? That'd be cool,
I don't think
right?
the Earth has enough oxygen to support those animals at that time.
Okay, interesting. Yeah. Yeah, I'd have to think about that. But yes, I mean, we obviously don't have temperature readings, but we have indices. We have surrogate measures, isotopes. We have, for hundreds and hundreds of thousands of years, gas bubbles that are trapped in glaciers. But yeah, and then what they do is that they take these surrogates and they match them to climate change over the last 100 years and make sure that they are actually good indicators, that they actually do work, and then they...
I think, we are polluting the air and making it hard for us. But I'm just wondering if this warming is just part of the Earth's cycle of warming, like it did cooling too. So.
Right, yeah. So that's good. The Earth just doesn't kind of warm or cool without a physical cause, right? And so that's why I tried to show here is that the scientists have looked at what are the physical causes and consequences over the last millions of years, and there are many of them, but none of them hold true today with the exception of greenhouse gases. So, yeah. Yeah, in the back.
Yeah, this certainly is a global situation, and I can think, okay, domestically here as a U.S. citizen, but how is this going to evolve throughout, all the so many nations that have to come on board to some extent,
Mm-hmm.
and so how do you see a pathway regarding that?
Right, yeah. Yeah, that's a really good question, a difficult one. Close to, you didn't say this, but it's close to a question I'm commonly asked of, well, what about China? Or what about India? Because we can do everything we can, and if they don't change, then we're still sunk. Okay, so let me address the question you didn't ask first, and that is, what about China and what about India? We're not going to fall off a cliff. The Earth is not going to become uninhabitable for life, and it's not going to become uninhabitable for human life. It's going to get progressively worse and progressively worse. So any little thing we can do to forestall, delay, or counter climate change will have some small benefit, and in aggregate, larger benefit. So we're not just going to drop off a cliff, right? So even if the other countries don't come on board, whatever we do will help the Earth's climate. But really it comes down to international treaties like the Paris Climate Agreement and then having some teeth behind them. And unfortunately, the richer companies need to help the poorer countries. There's a lot of talk about, well, the richer countries got where they're at because they burned fossil fuels and developed their economies. Why are we going to deny that to, let's say, sub-Saharan African countries? There's a lot of truth to that. But we are not saying, okay, because our technology has developed along a certain pattern, because our telecommunications has developed along a certain way, we want you to develop your telecommunications similarly, and you need to start with a little black dial telephone. No, they already have cell phones, right? We leap them forward to the most advanced technology available now. And actually, the cost of several renewable technologies for producing energy, solar and wind is now less than the cost of building power plants. So, and you can do it on small scale. You don't need a massive grid to move all the energy around. So we can do things like that with the modern technology. Yeah, aside from that, we do like to point fingers at India and China because they are massive greenhouse gas emitters. China is actually well ahead of us in terms of technology for advancing renewable energies. And there again, we don't want to be left behind in the dust. Do we want the rest of the world buying China's products, or would we like to have them buy our own? So kind of talking around an answer and not really getting directly to it, but those are some thoughts. Yeah. Yeah.
One thing you haven't mentioned is something that would get us over the hump. You mentioned,
Natural gas is
natural
one.
gas
Yeah.
is one. What about nuclear?
Yeah. What about nuclear?
Embracing nuclear at
Yeah.
this juncture.
Yeah.
Till we can come up with renewables that'll take, in quantities to
Right.
replace fossil fuels.
Right. Yeah, what about nuclear? That is fraught with,
Political.
yeah, it's political, it's, yeah, but I know a number of strong environmentally inclined scientists who advocate that, yeah, nuclear to get us over the hump might be the way to go. Of course, nuclear would be great if it weren't for 2 or 3 problems, right? What do you do with the waste? And how do you keep the waste from falling into the hands of people you don't want to have access to? And then the possible for, like, you know, a Chernobyl meltdown or something. So those are all very serious problems. But there are some people who argue that we can manage that, and it's worth the risk of doing that versus continuing on our slide toward a dramatically altered environment or climate.
One comment on that was one of the big problems is what you do with the waste.
Yes.
Right now, each state is responsible for its own nuclear
Yeah.
waste. So we have 50 waste repositories and more.
Yeah.
And up until the 90s, we were planning on Yucca Flats. and
Exactly. Yeah.
For all of the national
Yeah.
waste
Yeah.
to go and be buried underground
Mm-hmm.
in
Mm-hmm.
controlled
Mm-hmm.
caves. And that
Seems that we need a
global political problem.
yes. Seems to me we need a national or a federal, you know, program for kind of reining all, yeah, bringing that to a solution. Yeah.